Find the derivative of function 5x cubed minus x plus 1. So here, derivative, which we can write f prime, or we can write df dx, or we can write df of x over dx. All these three notations mean the same thing. So f prime of x, we have to use power rule for the first term. So we can think as we're taking three different terms, derivative. So if 3 times 5 x to the 3 minus 1. And here we can see that 1 is implied here. So we have negative 1 times x, 1 minus 1. And derivative 1 is just 0. So if we simplify, we have 15 x to the second power. Now this is minus 1. X to the 0 power is 1. So here we just have negative 1. And derivative 0, derivative 1 is just 0. So this is the derivative of function f of x, which also represents instantaneous rate of change. Find the derivative of function 4x squared minus 7 e to the x. So here again, we think about taking derivative as two different functions. So df dx is, first one we use power rule, which is 4 and times 2 x to the 2 minus 1 minus 7 times derivative of e to the x, something you have to remember. Derivative of e to the x is just e to the x. So here, derivative of e to the x is just e to the x. So if we simplify, derivative is 8x to the 1 power minus 7 e to the x. Find the derivative of 8x to the 4th plus 9x squared minus 1. So here we just use power rule. So I do 4 times 8, x to the 4 minus 1, plus 2 times 9, x to the 2 minus 1. And derivative of 1, derivative of any constant is just 0. So we don't need to write anything there. If we simplify, we get 32 x to the 3rd power plus 18 x to the 1 power. So this is the derivative of function f of x. Find the derivative of function x to the 4th plus 2 over x. Now here, for this part, we can just use the power rule. But what do we do here? So before we actually proceed, we can rewrite this function as x to the 4th plus 2 times x to the negative 1 power. Because 1 over x is equals to x to the negative 1 power. The reason we do that is so that now we can just apply the power rule. So f prime of x is 4x to the 3rd. I multiply 4 and subtract 1 in the exponent. And here we do the same thing. Plus 2 times negative 1 times x to the negative 1 minus 1. Which we get 4x to the 3rd minus 2 x to the negative 2 power. And we can rewrite it as a fraction. So minus 2. And now this portion right here can be written as denominator, but positive exponent. So this is the derivative of function f of x. So every time we have a variable input quantity on the denominator only, we can bring it up to numerator by changing the sign of exponent. Find the derivative of 3x times the entire function of 18x to the 4th plus 13 over x plus 1. So for this one, first we need to multiply these out. So we have f of x equals 18 times 3 gives us 54. X to the 5th power plus 39x over x plus 1. Now, when we take the derivative of each function, this one is just simply power rule. But the one on the right, we have to use quotient rule. Quotient rule. So let's do one at a time. So let's actually take the prime, which is the derivative, equals, I do 5 times 54, which gives me 20, 25, so 270. So I have 270x to the fourth power. So just applying the power rule. Okay. Now I have to apply the quotient rule, right, in different color. The quotient rule says, first, well, the bottom function is just square, and then derivative of top function. So let me actually write it. Derivative of top function times just the bottom function itself minus top function times derivative of bottom function. So the order is important in quotient rule. Okay. So let's keep simplifying. So here this one just stays the same. Plus x to the 1 square. Now let's find the derivative of this, which is just 39. So 39 times, keep the parentheses here, x plus 1, minus 39x times, now derivative of this is derivative of x plus derivative of 1. Derivative of x is 1, so I do 1, and derivative of 1 is just 0, so I'm just multiply by 1. So I can simplify furthermore. Distribute 39, 39x plus 39 minus 39x. This is just 39x over x plus 1 square. Then we'll see that this 39x cancels out. 270x to the fourth plus 39 over x plus 1 square. So this is the derivative of this function right here. Find the derivative of this function f of x equals x plus 2 multiplied by 2x squared minus 3. So here we have two choices. We could actually FOIL this out, and we have 4 terms, then apply power rule to each of the terms. We can also use product rule. We can see this as a first function, second function. So I'm actually going to do product rule, so we can practice product rule. So important thing all these rules that you need to be able to recognize what rule to use when. So here we have two functions multiplying. This multiplied by this. So if I find derivative of function respect to x, so I can write it this way: derivative of first function times just the second function without derivative plus derivative of second function times just the first function. Oops, that's x plus 2. So here I find the derivative of x plus 2, which is just 1 because derivative of x is 1. Derivative of 2 is 0. So I have 1 times 2x squared minus 3 plus derivative of 2x squared minus 3. So derivative of 2x squared, apply the power rule. I get 4x to the first power. Derivative of negative 3 is 0. So I only have 4x times x plus 2. So we can simplify. This is 2x squared minus 3. I can distribute 4x here. I get 4x squared plus 8x. So we can simplify to, let's see, we can collect like terms. If you look at here, we have 6x squared plus 8x minus 2. So this is the derivative of this function right here. Oops, sorry, I meant to write 3 right here. 3 from here. This is 3. Okay. Find the derivative of function x squared times 2 over x squared plus 5 over x cubed. So for here, first we have to remember, like here, 0 is not in domain. 0 is not in the domain. Okay. So for this entire function, we cannot plug 0 in. So that's the letter imply. So the reason we need to keep that in mind is because before we take the derivative, we can actually simplify this function. We can distribute x squared 2x squared over x squared plus 5x squared over x cubed. But because we already know that 0 is not in domain, we could simplify this. We can simplify this to 2, x squared cancels out, plus 5 over x. Okay. So now if you look at here, as you can see, 0 is not in domain still, right? But even if this x somehow cancels out in the denominator, we always have to just remember 0 is not in domain. We're simplifying for this purpose of finding the derivative. Now we can look at this and take the derivative. We can also rewrite this as 2 plus 5x to the negative 1 power. The reason we do that is that we can apply the power rule to this term right here. So then if I take the derivative of f respect to x, derivative of 2 is just 0. Instantaneous rate of change is 0. It doesn't change. Then for derivative of this one is negative 1 times 5x to the negative 1 minus 1, subtract 1 to the exponent, which I get negative 5x to the negative 2 power. Then we need to rewrite it as negative 5x to the second power. So this is the derivative of this function. Find the derivative of function x cubed plus 2x squared minus 4 over 3. So if you look at here, we could use a quotient rule. Okay? Top function, bottom function, numerator, denominator. But actually, quotient rule is not necessary. It's simpler to do. Since 3 is a common denominator, we can rewrite f of x as x cubed over 3 plus 2x squared over 3 plus negative 4 over 3. Or let's just write minus 4 over 3. So we can separate this into 3 different fractions because 3 is a common denominator. So then we have these 3 terms, and we just apply power rule to each of the terms when we find the derivative. So when we find the derivative, this one right here, you can think as is 1 over 3 times x to the third. So we have 3 times 1 over 3, x to the third minus 1, plus 2 over 3. Oops, let me actually multiply first. One, the order doesn't matter. Multiplication order doesn't matter, right? But I'm going to write 2 times 2 over 3, x to the 2 minus 1. And derivative constant is 0. So if you simplify, 3's cancel out. We have x to the second power plus 4 over 3 x to the first power, which is just x. So this is the derivative of this function right here. And if you use a quotient rule, you will still get the equivalent thing. But simplifying, rewriting this way is a lot faster than using a quotient rule here, because quotient rule is not necessary here. Find the derivative of function 4x cubed minus 2x plus 1 over x squared. So here we have to use quotient rule. Okay. Well, we're going to use quotient rule, so we can practice quotient rule. We could also technically just separate into 3 fractions, but let's use quotient rule. So let's use this notation, df dx equals, first the bottom function, entire bottom function, we square it. Okay. Over, now derivative of top function. So top function, let me write this card. Derivative of top function, 4x cubed minus 2x plus 1. Multiply by just bottom function itself, which is x squared. Minus, not plus, minus, now derivative of bottom function, respect to x squared. Multiply by just top function, like this. So then let's take the derivative. So bottom is just, maybe I don't need that long. Bottom is x to the fourth. And in the numerator, we have, now let's take derivative of each of these one at a time using power rule. 12x to the second minus 2. Keep the parenthesis, very important to keep the parenthesis, times x squared. Now, this derivative 1 is 0, that's why there's nothing here. Minus derivative of x squared is 2x, and keep the parenthesis. Now we need to simplify. We can multiply x squared here, negative 2x here. Distribute. So we have 12x to the fourth minus 2x squared minus 8x to the cube plus 4x squared minus 2x over x to the fourth. So we can collect like terms, 12x fourth negative or minus 8x cubed, and these two can combine to positive 2x squared minus 2x over x to the fourth. So this is the derivative of this function right here. Actually, I'm sorry, I made an error. Let me fix that real quick. When I distribute this right here, negative 2 to this should be actually 8x to the fourth, not third power. Okay. So that when we collect like terms, we can do this minus this, which gives me 4x to the fourth plus these two, which is positive 2x squared minus 2x over x to the fourth. So this is the final answer. So earlier I made a quick the distributing mistake. So this is the derivative of this function right here. Find the derivative of function x squared plus 4 over x squared minus 4. So here we have to use quotient rule. Again, it's important to recognize when to use quotient rule. Here we have a function over another function. Okay, so f prime is bottom square, so the bottom function square, which is x squared minus 4 square, entire thing, derivative of top function. So let's write derivative of top function. Let's denote it first. Prime times x squared minus 4, which is the bottom function, minus derivative of bottom function, x squared minus 4 derivative, times top function by itself. Okay. So build a habit to write a step first before you take the derivative straight away. So then derivative of this is just 2x times x squared minus 4. Derivative of this is 2x, derivative of 4 is 0. Minus derivative of x squared is 2x times x squared plus 4, entire thing, over x squared minus 4 squared. So then we can distribute 2x, negative 2x. We get negative 2x cubed minus 8x minus 2x cubed minus 8x. Oops, this should be positive. I don't know why I wrote that minus. Positive here. Over x squared minus 4 over square. So then these will cancel, but these two will be negative 16x over x squared minus 4 over square. So this is the derivative of this function. Find the derivative of x times sine x minus cosine x. Now if you look at here, first you need to be able to recognize that you have to use product rule here. This is just regular taking derivative of cosine. So if I take y prime, here I have to use product rule. So derivative of x times sine x plus derivative of sine x times x minus derivative of cosine x is negative sine x. So then derivative of x, so this is prime, derivative of x is just 1, sine x, derivative of sine is cosine, so plus cosine x times x, minus minus becomes positive sine x. So we can collect like term. We have 2 sine x plus here we have cosine x times x. So let's write it actually x times cosine x. Okay. So this is the derivative of this function right here. So here we had to use a product rule. This means we are multiplying two functions, this times this. Find the derivative of sine x times cosine x. Here we have to recognize that we have two functions and multiply, sine x times cosine x. Therefore, we must use product rule. So it's very important to recognize what rule to use first. So if I take the derivative of y prime, actually let's use different notation, just because we need to be comfortable with both notation, dy dx equals derivative of first function times second function. Now here we're taking only derivative of sine, plus derivative of second function, cosine x, times just the first function. So then we know derivative of this derivative of sine x is just cosine x. So we have cosine x times cosine x. Derivative of cosine is negative sine. So we have plus negative sine x times sine x. So then this we can simplify to cosine square x minus sine square x. So this right here is the derivative of sine x times cosine x. Find the derivative of x minus 1 over 2 times sine x. So dy dx is this one, derivative of x is just 1. And derivative of 1 over 2 sine x is minus 1 over 2 times just derivative of sine x, which is cosine x. So derivative is just 1 minus 1 over 2 cosine x. Find the derivative of y equals 1 over x plus tangent x. So let's rewrite this, y equals x to the negative 1 power, so we can apply the power rule. Plus, for tangent, we can actually rewrite this as sine x over cosine x. Because if you write as sine x over cosine x, we can apply quotient rule. We know the derivative of each sine and cosine. So let's find the derivative, which is negative x, negative 1, minus 1, plus, now here, derivative of sine over cosine is first cosine square x, in the bottom function square, then derivative of top function. So let me actually just do one step at a time. Derivative of top function times bottom function minus derivative of bottom function, which is cosine x, bottom function, times just top function. So let's go to the next line and simplify. We have negative x to the negative 2 power plus cosine square x. Derivative of sine is cosine times cosine x minus derivative of cosine is negative sine x times sine x. I guess I can put parentheses here too. So let's simplify. This one we can rewrite as negative 1 over x to the square, sorry, negative 1 over x squared, plus, now we have cosine square x. This is sine square, but now we have negative negative, so we have plus sine square over cosine square x. So let's simplify furthermore here. We have negative 1 over x squared plus, now this right here is one of the Pythagorean trig identity. Cosine square x plus sine square x is 1. So you have 1 over cosine square x. And we know that 1 over cosine square x is same as secant square x. So this is the derivative of this function right here. So here's the important thing. We just have observed that derivative of tangent x is actually secant square x. So for this is one of those things you can either remember this or you can derive by changing to sine over cosine. Find the derivative of y equals 2 cosecant x. So here we can rewrite cosecant as 2 times cosecant is 1 over sine x, which is same as just 2 over sine x. So then we can apply quotient rule here. Quotient rule to find this derivative. So then y prime is first sine square x in the bottom, derivative of top times, well, let me use different color, derivative of top 2 prime times just the bottom function minus derivative of bottom function times 2. So let's simplify. Derivative of 2 is 0. So we actually have 0 times sine x, which entire thing will go away. So this is 0. Minus derivative of sine is cosine. So we have 2 cosine x over sine square x. So again, this is 0. So what we have is negative 2 cosine x over sine square x. And we can actually rewrite this as negative 2 times cosine x over, let's do sine x times sine x. So we can think this as 3 things, negative 2 cosine over sine and 1 over sine x. So if negative 2 cosine over sine is actually cotangent, and 1 over sine is cosecant x. Okay. So actually, here's another observation. Derivative of cosecant x in general is just negative cotangent x cosecant x. This derivative of cosecant is negative cotangent cosecant, or negative cosecant cotangent. Multiplication or doesn't matter. But the reason we have 2 here is because of this 2. The constant was multiplied. So this is okay, and one of those derivatives you can either remember or you can always derive by rewriting in terms of sine over cosine and apply the appropriate rule to find it. Find the derivative of secant square x. So for this, we need to rewrite it as 1 over cosine square x. And then we can apply the quotient rule. We can apply the quotient rule. So if I apply the quotient rule, the bottom function, entire thing square. On the numerator, derivative of top function, 1 prime times bottom function, cosine square x, plus, minus cosine square x prime times 1. So let's simplify a little bit before we find the final answer. So here, this derivative is 0. So this entire thing is just 0. So we have minus cosine x square prime. But I'm actually going to write cosine times cosine like this. This is same as cosine square. And times 1. We don't need to write it anymore, right? Over cosine, well, let's make it fourth power now, fourth power to the x. The reason I wrote this way is so that I can now find the derivative of this by applying the product rule. Product rule. So let's write the product rule in the next line. Again, it's negative of the entire thing. Derivative of first, well, in this case, first and bottom function, first and second function are same. So we can write derivative of cosine times cosine plus derivative of cosine times cosine over cosine to the fourth power. So then derivative of cosine is negative sine times cosine x. Same thing, sine x, negative sine x, cosine x over cosine to the fourth x. Now here we have minus, well, we can think as negative sine x cosine x, negative sine x cosine x. So it simplifies to minus negative 2 sine x cosine x over cosine fourth x equals, now this is positive, 2 sine x cosine x over cosine 4 to the x. Now we can simplify furthermore. Again, in general, if the function is given not in, like secant square, we want to rewrite it not in terms of like fraction like this, since it was not given as a fraction. Okay, so we can simplify. We can think as we have sine x times cosine x over, we have cosine x 4 times here, right? Cosine x, cosine x, cosine x, cosine x. So I can rewrite as cosine x times cosine x to the third now. Let me rewrite that. X to the third x, third power. So this portion becomes tangent. This portion simplifies to one of them cancels out, so I have only cosine square. So what I have left as a final answer is 2 times tangent x. And here again, I have 1 over cosine square x, which is secant square x. So this is the final derivative. This is the derivative of this function. Find the derivative of function square root of x plus 3 over cosine x. So here we have to use quotient rule. Again, it's very important to recognize what rule to use first. That's the first thing we're practicing here. Quotient rule. Like what rule to recognize is the skill we need to develop. So then df dx equals the bottom function, entire thing square, top function derivative, square root of x. So actually for square root of x, let's rewrite it as x half power plus 3, entire thing, I'm noting different notation, d dx of this times cosine x minus derivative of cosine x times just the function x to the half power plus 3. So let's take the derivative. We have half x negative half power. derivative of 3 is 0 times cosine x minus derivative of cosine is negative sine x times x to the half power plus 3 over cosine square x. So let's simplify. This one we can rewrite as 1 over 2 square root of x times cosine x plus sine x, negative negative becomes positive. Now we can rewrite as square root x plus 3 over cosine square root of x. So let's simplify furthermore. We can just write cosine x over 2 square root of x plus, we could distribute this, so we have square root of x times sine x plus 3 sine x over cosine square root of x. So this right here is the derivative of this function right here. Find the derivative of g of x equals e to the x over x. So we have to use quotient rule here. So it's important that you recognize that you have to use quotient rule. So then g prime is bottom function square, derivative of top e to the x prime times just the bottom function from here, minus derivative of bottom function times e to the x. So let's simplify. Derivative of e to the x is just e to the x times x minus derivative of x is 1, so we just have e to the x over x squared. So this is the derivative of this function right here. Find the derivative of ln x over sin x. So here we have to use quotient rule. Of course, it's important for you to recognize that we have to use quotient rule. So dg dx equals bottom function square, derivative of top function, so let's write d dx of ln x times sin x minus derivative of bottom function, which is sin x, times ln x. So derivative of ln x, remember this, derivative of ln x is 1 over x. So we have 1 over x times sin x minus derivative of sine is cosine times ln x over sine square x. So let's simplify this. We have sine x over x minus cosine x times ln x, entire thing over sine square x. So this is the derivative of this function right here.